There's something magical about the ice sheet in the Arctic. Yes, it has a stark and majestic beauty, but more than that is the knowledge it contains. Because the ice sheet in the Arctic is deposited year after year and doesn't entirely melt. It grows, forming layer after layer, like tree rings, giving us a window into the atmosphere of the past. Arctic ice cores give us information, for example, about CO2 levels in the atmosphere over millennia of time. But if you were a researcher interested in, say, atmospheric lead levels, you'd find ice cores rather disappointing, at least for much of prehistory. Something changed rather dramatically, though, in those ice cores around 500 BCE. Lead levels started to rise quickly. And if you know a bit of history, I suspect you know why. This week, we are looking at atmospheric lead levels in the context of the Roman Empire. It's a story relying on data from this article by Joseph McConnell and colleagues appearing in the Proceedings of the National Academy of Sciences, and it's a story with contours that are eerily similar to the challenges we face today, the balance of industry and public health, and the strange interplay that a pandemic has on both. Now, it would be easy to think about lead as yet another, or perhaps the first, industrial pollutant, a byproduct of industry. But there is something a bit unique about Roman lead exposure compared to the exposure of a modern populace to industrial pollutants. Lead was useful. A malleable metal that was fairly corrosion resistant, it found its way into many areas of Roman life, and often, in contrast to modern pollutants, into the lives of the well-to-do. In Rome, exposure might have been higher among the elites. Romans consumed lead through myriad mechanisms. Lead acetate was used to sweeten wine, a luxury afforded to the upper crust. Lead pipes were famously used to transport water into homes and bathhouses in urban areas, again, inadvertently protecting poor rural Romans from exposure. High-class women in Rome used makeup containing lead. Coins were often adulterated with lead, leading those who handled money to get more exposure. It's quite unusual to see a public health situation that affects the powerful more than the powerless. Some scholars have even argued that the decline of the empire was due in part to lead decreasing the fertility and IQ of those running the place. But it won't surprise you to hear that the little guy wasn't entirely spared. One major source of lead pollution that preferentially would have affected the lower classes was atmospheric pollution from smelting. This is Rio Tinto in Spain. During the Republican period of Rome, it was a major mining area, thanks to its abundant mineral deposits, including iron and silver. Silver was smelted here from galena, a lead-rich ore, resulting in the production of around 2,000 ounces of lead for each ounce of silver obtained. Some of that lead ended up in the atmosphere and, carried by fine dust particles and blown by winds aloft, ended up in Arctic ice cores that we can measure today. So let's take a look then at the levels of lead in the ancient atmosphere. What you see in the black line is atmospheric lead levels above background from around 450 BCE to around 165 CE. This may as well be a line depicting the strength of the Roman economy over time, with dramatic increases in the heyday of the Republic, followed by a dramatic slump during the transition to empire, followed again by a stable, thriving economy during the Pax Romana. Lead, a toxin, a pollutant, is a marker of economic productivity. Sound familiar? Now, I only showed you part of the graph ending at 165 CE for a reason, and history buffs might recognize the date. It's the start of a pandemic, the Antonine Plague. The symptoms of the Antonine Plague were described by the Greek physician Galen: fever, sore throat, and a pustular skin eruption. We don't know what pathogen was responsible for the plague, but given the transmissibility and 25% death rate, 5 to 10 million deaths, that's about 10% of the empire, it was probably smallpox. Now, we know all too well how pandemics can affect an economy, and the effects of the Antonine Plague are written in Arctic ice sheet lead levels. You see dramatic declines in lead levels during the plague that never really rebound, save for a brief spike during the Valentinian dynasty that I am in no way qualified to explain. Those red dots, by the way, that's the amount of silver contained in denarii coins. As the economy falters and silver, and therefore lead, production diminishes, less of the precious metal was used in coin making. Now, during the Pax Romana, when lead production was at its peak, the effects would have been noticeable on a population level. This map shows atmospheric lead levels across the empire. The highest are, of course, centered around Rio Tinto in Spain, the primary silver smelting location. Estimates put the atmospheric lead there at around 10 nanograms per cubic meter. That's nothing to sneeze at, but just for a bit of context, when leaded gasoline was still in use prior to the Clean Air Act, U.S. atmospheric lead levels were nearly 1,000 times higher. United States atmospheric lead levels reported by the EPA in 2023 were 27 nanograms per cubic meter. That's still 2.7 times higher than peak Roman levels. Nevertheless, the researchers could model how that atmospheric lead level would increase blood lead levels in the population. And because we now know of the association between blood lead level and IQ, they could model how many IQ points would be lost due to lead across the Roman Empire. Now, it's important to note that baseline blood lead levels were higher in the Roman Empire due to the ubiquity of the element. So these atmospheric increases add to a relatively higher starting point. As such, they model around a 3-point loss of IQ around much of what is now Spain and Portugal, and 2.5 points in the heart of the empire. Practically, this represents a minimum, since atmospheric lead was just a small portion of the lead exposure a typical Roman might receive. In fact, a study of tooth enamel from Roman burials revealed blood lead levels ranging from 0.3 to 1,800 micrograms per deciliter. We currently use 3.5 micrograms per deciliter as a threshold for more monitoring. Of 173 skeletons examined, only 7 had implied blood levels below that threshold. What this means is that, yes, smelting contributed to Roman lead exposure, but in reality, lead exposure was much higher for many Romans due to the pervasive use of the material in everyday life. It probably wasn't great to be a galena smelter at Rio Tinto, but most Romans would have experienced atmospheric lead levels lower than you and I do. I'm taking home a few lessons from this paper. One is just the interesting fact that industry and pollution and economies are often tied together. We can measure the Roman economy in lead deposits, and perhaps future historians will measure our economy in CO2 emissions, unless we have the ingenuity to break the cycle. The other lesson is that if you don't know something is toxic, it's really hard not to be exposed to it, especially if it's useful. One can only wonder what highly useful substance we are exposing ourselves to now that might in the future be shown to be damaging to our health. Lead was a useful byproduct of silver mining. I suppose the modern analogy would be useful byproducts of oil drilling. Microplastics, I'm looking at you. In any case, to borrow from a Romance language. Plus ça change, plus c'est la même chose. For Medscape, I'm Perry Wilson.